Hello everyone, I hope you have studied a lot about the semiconductor basics, and today we will start with the topic diode, which is also called as semiconductor diode. First, the question arises, what is diode? A diode is a two terminal unidirectional power electronics device having two electrodes, that is anode and cathode, where anode stands for positive sign and cathode stands for negative sign. Now, diode is the first semiconductor device which came into existence, and its name is derived from two words, that is, if we bifurcate diode into two parts, that is di and ode. Here di means two and ode means electrodes. So, the word ode comes from electrodes. So, the device which is having two electrodes is called as diode. The semiconductor diode is the first invention in a family of semiconductor electronics devices. As we all know, there are a lot of semiconductor devices present in today's scenario, in which diode is the first device which came into existence. After that, new inventions came and a lot of semiconductor devices came after that, which fulfills the drawbacks or the limitations of diode. A diode is a device which allows current to flow only in one direction and it blocks the current in another direction. That means, if we provide a voltage source with the diode, it allows the current to flow in only one direction and it blocks the current in opposite direction. So, from this we can conclude that it offers a low resistance, or ideally which is called as zero resistance in one direction, and secondly it offers high resistance, or ideally we can say that infinite resistance in another direction. Here the picture shows about the symbol of diode, which is showing two part. One is the arrowhead and second is bar. The symbol of diode can be divided into two parts, one is called as arrowhead and second is called as bar. So, the arrowhead shows the direction of current flowing through the diode. So, from the symbol we can say that the current in a diode flows from anode to cathode and it blocks the current from cathode to anode. Next figure shows the figure of the diode showing its junctions and two parts, that is p type silicon and n type silicon. So, we can also say that the diode is a device which is having two electrodes and it has one junction. Now, let us study something about the semiconductor devices and its classification. As I have already told that there are a lot of semiconductor devices which comes into existence, and lots of devices are used in present scenario. So, one of the classification is on the basis of their on and off condition. So, first classification is the uncontrolled turn on and uncontrolled turn off devices. The devices in which we cannot control its on condition and as well as we cannot control its off condition. So, the semiconductor diode comes under this category. So, in diode we cannot control its on condition as well as we cannot control its off condition. As soon as we switch on the supply, diode starts working, and as soon as we switch off the supply, diode stops working. So, its working totally depends upon the on and off condition of the supply. Second category is controlled turn on and uncontrolled turn off devices. So, these are the semiconductor devices in which its on condition can be controlled, but its off condition cannot be controlled. So, the example for this device is a thyristor, which is also called as SCR. So, in thyristor we can control its on condition by giving a gate pulse. So, as soon as we switch on the supply of the circuit in which thyristor is placed, the thyristor will not get on until we give gate pulse, but as soon as the supply gets off, the thyristor gets turned off. So, in this manner thyristor comes under the category of controlled turn on and uncontrolled turn off devices. Third category is the controlled turn on and controlled turn off devices. That means the devices in which we can control its on condition and we can also control its off condition. An example of this type of devices are all the modern semiconductor devices which are being used in the power electronic circuits. Example, IGBTs, MOSFETs, GTO, etc. Now, let us study about formation of depletion region. How the depletion region is formed in a diode. As we all know, the diode has two layers, P and N. Since it is made up of two types of extrinsic semiconductor material, P type and N type. Now, both this P type and N type materials are chemically combined with a special fabrication technique to form a p-n junction. So, here our diode is nothing but a p-n junction device which is having one layer of P type and one layer of N type, and between that depletion region is formed, and we can say that a junction is formed between this P and N type. Now, let us study about the p-n junction. As we all know, in N type material large number of free electrons are present, that is why its name is called as N type. And similarly, in P type material large number of holes are present. Now, as I am saying, the large number of free electrons and large number of holes are present, that means they are the free charge carriers which are present in that type of material. As we can see in the below picture, first we can see in N type picture there are some free electrons which are ready to recombine with other with the holes or any free holes. Similarly, in P type material the vacant holes, or we can say that free holes are present which are ready to recombine with the electrons. So, N type and P type both are rich in carriers. N type are having free electrons and P type are having free holes. Now, let us see what all process takes place in the p-n junction. So, the following process takes place when p-n junction is formed. First, the free electrons from the N region starts diffusing into the P region. Similarly, holes from the P region starts diffusing into the N region. As we all know, we have studied in just now that in P type material the free charges are the holes, and in N type material the free charges are the electrons. So, when the P and N junctions are formed, the free electrons from the N region starts diffusing into the P region. Here the diffusing word means it is moving from the N region towards the P region. Similarly, the free holes from the P region starts diffusing or starts moving from P region to the N region. Now, in the below picture we can see from the N region electrons starts moving and they get accumulated at the boundary of the P region. Similarly, the free holes diffuses from the P region and moves towards the N region and gets accumulated there. So, in this way the diffusion process takes place in p-n junction, and by this we can say that a region is formed which is called as depletion region. Here one thing we can also see in this figure, that the electron drift and hole drift also takes place. Now, what is drift? As we all know, the majority carriers in N region are the electrons and the minority carriers are the holes. Similarly, the majority carriers in P type are the holes and minority carriers are the electrons. So, the movement of or the motion of the majority carriers from, suppose from n region to p region, is called as diffusion. Similarly, the movement of the minority carriers from n region, that is hole from the n region towards p region, is called as drift. So, for the majority carriers, here the electrons diffuse from n to p region, and the majority carriers in p region, that is holes, move from p region to n region. Similarly, the minority carriers from n region, that is holes, drift from n region to p region, and the minority carriers in p region, that is electrons, drift from p region to n region. Due to the presence of holes as acceptor atoms in p region, electrons diffused from n region fill these holes, which results in accumulation of negative charges in the p region. Now, as we have studied just now, that the free electrons are in search of holes so that they can recombine with them and accumulate at a particular position. So, the majority carriers, which are the electrons, move from n region and they move towards the p region, and since there are the holes as acceptor atoms, so the electrons diffuse from n region and fill these holes, or we can say that they recombine with the holes and accumulate at the p region in the form of negative charges. So, we can say that negative charge get accumulate in the p region. Similarly, we can say that the donor atoms, that is the electrons, gets recombined with the holes diffused from p region, which results in increased concentration of positive ions in n region, which means that the holes which are the majority carriers, which moves from p region to n region, they recombine with the electrons, and a positive charge is accumulated, or we can say that a positive ions concentration gets increased at the boundary of the n region. So, this thing can be explained with this diagram. So, here are the three diagrams. In the first figure, we can see a normal p n junction, where the majority carriers in p are the holes and majority carriers in the n type are the electrons. So, after diffusion, the majority carriers holes or the positive ions get diffused towards the n type material, and the electrons get diffused from n to p type material. So, when the diffusion process gets completed, we can see that a depletion layer is formed. So, the third figure shows the formation of depletion region, in which a negative charge gets accumulated at the boundary of p region and a positive charge gets accumulate at the boundary of n region, and the combination of this negative and positive charge forms a depletion region. Now, once the depletion process gets over, the electrons experience a force of repulsion while diffusing from n region to p region when sufficient negative charges gets accumulated in p region. Similarly, holes experience a force of repulsion when sufficient positive ions gets accumulated in n region. As we have seen in the last figure, a lot more negative charges get accumulated in the p region and the positive ions get accumulated in the n region. So, both these electrons and holes will experience a force of repulsion while diffusing from their respective region. So, once this force of repulsion gets over, or we can say that the depletion layer is formed, and that condition is called as equilibrium condition. So, what happened in equilibrium condition? In equilibrium condition, there exists a layer of negative charges in p region and positive charges in n region. So, what we have seen in the last figure is that is the equilibrium condition. So, when the force of repulsion gets over, there exist negative charges at the boundaries of the p region and the positive charges in n region. So, this can get more clear with this diagram. Here the positive ions get accumulated around the n region, the negative charges gets accumulate on the p region. So, this figure shows the equilibrium condition, and this situation is formed after the depletion region is formed and it is get completed. Now, the region near the junction consists of negative and positive charges without any free electrons and holes. So, we have seen in the last figure that at the junction point it consists of negative and positive charges without any free electrons, since all the free electrons and all the free holes gets recombined with each other, and only electrons are accumulated in the p region at the boundary of the p region, and the holes or the positive charges gets accumulated near the n region. Since the region is depleted of the free charge carriers, hence the region is called as depletion region or depletion layer. So, the word depletion came from here only, since no free charges are depleted from any of the layers. So, in this way depletion region, or we can say that depletion layer, is formed. Due to the presence of negative and positive charges on opposite sides of junction, a potential develops across the junction, and it is called as barrier potential or junction potential or cut in voltage. As we have seen, the charges gets accumulated, the opposite charges gets accumulate, one at the p side and one at the n side. So, here due to the presence of negative and positive charges on the opposite junction, a potential will develop at this junction. That means a voltage will occur at this junction, and that is called as barrier potential or junction potential, or it is also called as cut in voltage. Now, let us study about barrier potential. The electric field that is produced in the depletion region acts as a barrier. Now, why this is called as barrier? It is a potential or a voltage which occurs between p layer and n layer, and it is called as barrier because the current will not flow from p region to n region until and unless this voltage is overcome. That is called it, and that is why it is called as barrier. Now, the external energy must be exerted to allow the electrons to get through the barrier of the electric field. So, to allow the current to flow from p region to n region, external energy is required. So, what I have said that this voltage or barrier potential or this potential of voltage should be overcome to allow the electrons to flow from p to n, or we can say that a current to flow from p region to n region, or we can say that to allow the current to flow from anode to cathode. Now, the potential difference required for the electrons to be passed across the electric field is called the potential barrier. As we have seen, this negative charges and positive charges forms a barrier which is in the form of potential, and some amount of voltage is required to overcome this potential. That is why it is called as potential barrier. So, this potential barrier can also be understood by this figure. One side is the n region, other one is the p region. So, around the p region, at the boundary of the p region, negative charges gets accumulate, and at the boundary of the n region positive charges get accumulate. So, they are acting as a voltage, or because they are forming a potential difference between the two region. So, we can see the positive voltage is occurring at the N region and the negative voltage is occurring at the P region. One more thing is important which should be noted here is that the amount of voltage, as the graph is showing, here the magnitude of the voltage is same, only the sign is opposite, that is the positive voltage near the N region and the negative potential around the P region. So, this is how a potential difference occurs at the depletion region. So, to overcome this voltage, or we can say that to allow the current to flow from anode to cathode, this potential should be overcome. The barrier potential is also called as height of barrier, which is about 0.7 volt for silicon and 0.3 volt for germanium material. So, the barrier potential which we have studied just now, it is also called as height of barrier, and as we all know, there are different type of materials from which the semiconductor devices can be made, in which the majorly used materials are silicon and germanium. So, the height of barrier, or we can say that the barrier potential for silicon material is 0.7 volt. That means at least external voltage of 0.7 volt is required to overcome the potential barrier, then only the current is allowed to flow from anode to cathode, and similarly this value is 0.3 volt for germanium. Now, the physical distance from one side to another side of the depletion layer is called as width of the layer. From the last figure we have seen a particular width is present in the depletion layer. So, the physical distance which occurs between the two layers is called as the width of the layer. Now, the depletion layer is practically very thin and of the order of 0.5 micron to 1 micron, where 1 micron is about 10 to the power minus 6 meter. So, the depletion layer which we have seen in the last figure, it is actually, or we can say that practically it is very thin, and it is measured in the unit of micron. Now, let us see what all factors are there on which the barrier potential depends. So, the barrier potential of a p-n junction depends on first the type of material. Just now we have seen that there are two type of materials which are majorly used, that is silicon and germanium. So, as the type of material is changed, the barrier potential gets changed. Similarly, the second parameter on which the barrier potential depend is the amount of doping. As we all know, doping is the impurity which is added in the material, so that free charge carriers or the majority or minority charge carriers are present or formed. So, the amount of doping also affect the barrier potential. The third factor is the temperature of the semiconductor. As we all know, the temperature is a very important factor in the field of semiconductor devices. By applying a temperature or by changing the temperature, we can change the property of a semiconductor, that is from insulating to conducting also. So, temperature is one of the factor on which the barrier potential depends. Now, let us see what are the applications of diode. As we all know, diode is a very widely used semiconductor device, whether it is a small voltage electronic circuit, that means for 5 volt or 12 volt, or we can say that power electronics devices in which the voltage level is of the order of kilovolts. Everywhere the diodes are used. In the power electronic circuits, these diodes are called as the power diodes. So, the application, the major application of diode is for the rectification purpose. As we all know, a rectifier is a device which converts AC signal into DC signal. So, main function or the working of diode is for the rectification of the electric signal from AC to DC. Second application is of a diode is as a switch. As we all know, there are logic gates. In the digital electronics we have studied about the logic gates. So, to form that logic gates, the switches are required, and that purpose is fulfilled by the diode. The third application is diode as a light source. Next is for source isolation, that is LED is used to transfer signal between two circuits without any electrical connection, and that is why it is called as isolation, source isolation. Next application of diode is as voltage reference, in which a particular special kind of diode called as Zener diode is used as a voltage reference. Next application of diode is as solar cell. As we all know, the solar power is used widely in the present scenario. So, to form a solar panel, this diodes are used, or we can say that to form a solar cell, these diodes are used. Next application is clipper, and next is clamper. So, clipper and clamper are also the major applications of diode, and last application which for which the diode is used is the circuit protection, simply to allow the current from one direction to another direction and block in the opposite direction. So, these are the applications, and from this we can say that diode are widely used in all the electronic circuits. So, in the future lectures which we are going to study in deep about the rectification process, how the AC signals gets rectified from AC to DC, and what all circuits are required for the rectification. Similarly, we are going to study in deep about the Zener diode, how it is different from a normal diode, normal p-n junction diode, and what are its working area. And similarly, we are going to study about the clipper and clamper. So, let us get a brief idea about clipper. Clipper circuit is used to clip, or we can say that remove some certain parts from the AC signal. That is why a word clipper is used, and it is called as clipper. Similarly, clamper circuit is nothing but it changes the position of the AC signal at a particular axis or at a particular reference point. If you want to change the signals of the reference from a particular point, the clamper circuit is used. So, these are the wide applications of diode. So, when the diodes are used in an electronic circuits, or we can say that at the voltage level of 5 volt to 12 volt, it is simply called as diode, and when it is used in a power circuit for at the power level of kilowatt or kilovolt, and at the voltage level of kilovolt, it is called as power diode. Thank you.